Question 3. Can you draw free body diagrams for the illustrations below? So we've got a sort of generic looking diagram on the left here, and some photos. A man walking across a plank, a little bridge here. So the man's going to be very heavy in contrast to the plank. And then we've got a concrete sort of bridge with two pylons. So we're going to come up with some structural simplified models of these problems. Here we've got something which is representing a hinge here, a pivot on rollers, so there's going to be no sideward forces because it would just move. And then we imagine those joints, all these locations here. So the first one to draw is a standard diagram showing you the problem. They usually come in this kind of form. So what are you going to draw for your free body diagram? Pause the video and then I'll reveal the answer. Okay, so we should have something like this. The distances are probably going to be relevant, so we'll keep them. Also, we're going to keep the nodes. They might be useful. So A, B, D, and C are kept there. We'll replace, little typo there, we'll replace the reaction forces with RAX and RAY, and the reaction force here, RCY. So it's telling me the name of the node and then what direction it's going to go in. And that's a suitable free body diagram. What about for the man walking along this plank? What would be a good free body diagram for that? Well, pause the video, and when you're ready, I'll reveal the answer. Okay. So the man doesn't seem to be necessarily in the middle, so we'll just say that there's a length L1 here, and then from the man to get to the end, a length L2. The man will have a certain weight, so I'll represent that by W. And the 3 points of interest will be the pivot there, A, where the man is B, and where the other sort of pivot is C. So that's something we'd probably use as a fairly meaningful structural diagram for the problem we've got here. Okay, now we've got a concrete bridge with two big pylon towers there holding it up. So what would be the free body diagram for this case? Pause the video and see if you can draw the right answer. Okay, so you should have a drawing where you've got probably just a UDL to represent the fact that we've got quite a lot of weight here all the way across, and we're going to have these two pivots here and here. There's nothing really of interest other than where the pivot points are. So with the A and the B, we need to know what that length is. R represents the UDL, the uniform distributed load, with it's going to be in probably quite a high number, so kilonewtons per meter. And I would want to draw a diagram something along those lines. Okay, so if you can draw diagrams like that, then you can do free body diagrams. Good stuff.